Welcome to The Explainer. Today, we're diving straight into a highly technical and honestly critical architectural overview, documented in the briefing titled SRL, Standby Redo Logs, Why and How. If you're a database engineer or architect managing Oracle DataGuard, you already know that configuring your redo transport correctly isn't just an option. It's literally the backbone of your entire disaster recovery strategy. So let's get into it.
Here's our roadmap for this explainer. 1. Introduction to Standby Redo Logs. 2. Why use Standby Redo Logs. 3. Standby Redo Log Best Practices. And 4. Real-time versus traditional archival.
Starting things off with Section 1, Introduction to Standby Redo Logs.
So what exactly are Standby Redo Logs, or SRLs? Well, they're a fundamental component of Oracle DataGuard. When you have them precisely configured, they allow the standby database to receive redo exactly as it's being transmitted from the primary database. Having SRLs present is really the key that unlocks real-time apply. It lets you process redo streams continuously, entirely bypassing the need to wait for archived redo logs to be created on the destination system. And what does that mean for you? It drastically reduces your redo apply latency and ensures a much tighter synchronization delta between your standby and primary databases.
Now, it's absolutely critical to understand how Oracle treats SRLs across different DataGuard protection modes. If your architecture demands maximum protection, standby redo logs are a strict requirement. There's no way around it, because synchronous transport in this mode depends entirely on SRLs to guarantee zero data loss. On the flip side, in maximum performance mode, where we commonly see asynchronous redo transport, SRLs aren't strictly mandatory for the database to function, but they are highly recommended by Oracle. Why? Because even with asynchronous transmission, configuring SRLs supports real-time apply, which improves your overall recovery capabilities and really streamlines role transitions, like switchovers and failovers.
Moving on to Section 2, Why Use Standby Redo Logs. Let's take a closer look at the systemic mechanics and why exactly we're configuring these logs on both primary and standby systems. To really grasp the necessity of SRLs, we need to trace the exact sequential generation of redo entries on the primary database. It all starts when a user transaction modifies data. Those redo entries are immediately written directly into the redo log buffer right within the System Global Area, or SGA. From memory, the log writer process, LGWR, takes over and flushes those redo entries from the buffer straight into the currently active online redo log, or ORL. Keep in mind, this local write happens regardless of your DataGuard configuration.
Simultaneously, Redo Transport Services has to ship this generated redo across the network. Depending on your protection mode, this transmission uses distinct background processes. For maximum protection, which requires synchronous transport, the network server process, NSN, manages that strict sync transmission. Alternatively, if you're operating in maximum performance using async transport, the network server async process, or NSN, takes over. Just a quick note for the engineers who might be migrating from older architectures, these NSN and NSN processes officially replaced the legacy Log Network Server, or LNS, background process starting back in Oracle Database 12c.
Now let's trace the data lifecycle once that redo stream actually hits the standby database. Redo Transport Services delivers the payload to the Remote File Service Process, the RFS. If you have your standby redo logs properly configured, the RFS writes that incoming redo stream directly to the current SRL. And since the data is landing in an active, structured redo log, the Managed Recovery Process, MRP0, can continuously read from that SRL and perform real-time apply. Meanwhile, an ARCN background process just waits until the SRL fills or a log switch is triggered to archive the completed log. It's a highly efficient machine.
But let's contrast that with the degraded operational state you end up in when standby redo logs are absent. Without SRLs, real-time apply is strictly unavailable, period. The RFS process just doesn't have an active log to write to, so it's forced to write the incoming stream directly into uncompleted archived redo logs. Because of this, the managed recovery process can't read the data continuously. Instead, MRP0 has to sit and wait until the primary database switches logs and that archived redo log is fully completed on the standby before it can apply a single byte. The end result? Significantly higher apply latency.
And you can't just bypass this limitation with initialization parameters. Some engineers attempt to use the archive lag target parameter to force periodic log switches and artificially push data over to the standby faster. While that parameter is a totally valid mechanism to limit the amount of redo contained in a single ORL and promote more frequent archival, it is absolutely not a substitute for standby redo logs or real-time apply. You should never rely on it as your primary architecture for minimizing redo apply latency or potential data loss.
All right, Section 3, Standby Redo Log Best Practices. Let's advance to the explicit configuration rules for Oracle Database 19c.
Systematically, there are a few physical configuration prerequisites you absolutely must adhere to. First, configure your SRLs on both the primary and standby databases. Yes, the primary doesn't use its SRLs during normal operations, but it absolutely requires them immediately following a switchover or failover when it assumes the standby role. Second, make sure all your online redo log groups are identically sized. This guarantees predictable log switching. Third, every single standby redo log group must be sized at least as large as your largest ORL group. And finally, you have to create SRL groups for every redo thread in the database, mapping them appropriately across rack environments.
Now, when it comes to calculating exactly how many SRL groups to provision, there is one non-negotiable mathematical rule in the Oracle architecture, the +1 rule.
For each redo thread, you must configure at least one more standby redo log group than the number of online redo log groups. Let's look at a practical example to put this into perspective. Say you have a 3-node Oracle RAC primary database, and each of those 3 threads has 4 online redo log groups. You must configure 5 standby redo log groups for each thread on the standby. That's 5 groups multiplied by 3 threads, giving you a total of 15 standby redo log groups. This N+1 rule is crucial because it ensures the RFS process always has a target SRL available during primary log switches, regardless of how many instances are actually running on your standby node.
Finally, Section 4, Real-Time versus Traditional Archival. Let's break down the mechanical differences on the standby system.
Comparing the mechanical states side by side really reveals the true impact here. With standby redo logs enabling real-time apply, your RFS destination is an active SRL. Because it's an active log, your MRP0 status is a continuous read, meaning it applies data modifications exactly as they arrive over the network, while the RFS is still writing to the file. Apply lag is effectively eliminated. Now, without SRLs, you're restricted to archive log apply. Your RFS destination becomes an uncompleted local archive log structure. Since the database can't safely recover from a file that's actively being written to, your MRP0 is forced to remain completely idle until the primary triggers a log switch. This introduces high and completely unavoidable apply lag.
So operating without SRLs introduces a constant artificial apply lag equal to the exact time it takes your primary database to completely fill an entire online redo log file. I'll leave you with this question to consider for your own environment's design. Will your disaster recovery architecture accept this forced delay? Or will you implement standby redo logs to keep your standby synchronized down to the very second? Thanks for joining me for this explainer.